Hi students. So we are discussing coordinations. So in last class we discussed the function of the brain. Brain is divided into three parts. One is forebrain, midbrain and hindbrain. So all the function is important. So in last class we also discussed what is CNS, Central Nervous System. CNS consists of brain and spinal cord. Actually, brain is completed and we have discussed about this spinal cord also. Spinal cord is a continuation part from the brain. So this is the spinal cord is continuations from the brain. The cerebrospinal fluid is also there in the brain and the spinal cord to protect the brain and the spinal cords. Actually, in the brains, we discussed there are gray matters and white matters. White matters is in the present of the center. So, but the gray matter is in the peripherals. So, exactly this gray matter and white matter is opposite in the brain. White matter is in the spinal cord. White matter is present in the peripheral. But the gray matter is present in the center. Gray matter is present in the center. Actually, in the brain, white matter is present toward the center. Gray matter is present toward the peripherals. This is the small difference between the white matter, gray matter present in the spinal cord, present in the brains. There are two scientists. The Greeks only believe that the functions is controlled by the brain only, but there are one more CNS is there, that is the spinal cord, also responsibly for the stimulating and responding for the sensations, and the motor nerves also connected to the spinal cord. It will also take the message and it will also give replies. There are two scientists. They did some experiment on the frog. One is Leonardo da Vinci and Stephen Hales. Leonardo da Vinci and Stephen Hale. They both did some experiment on the frog. Actually, in the frog, the brain has totally damaged. So, but when the brain has damaged, we can see there is no movements in the body of the frogs. But actually, what happens? They started some doing experiment on the frogs. When they observed very carefully in this frog, but there is no movements in their body. But when they are pricking on the body, what happens? They can see some muscles movements in their body. So they can see some muscles movement in their body. What happens? When they destroy the nerves, when the nerves are damaged in their body, in the frog, totally their body has collapsed. Actually, so both spinal cord and the brain are responsibly for the messages giving the replies of the bodies. So when the spinal cord are damaged, totally the frog body has collapsed. Both are very, very important in their bodies, both spinal cord and the brains. So this is about the central nervous system, spinal cord and brains. Next we will discuss PNS and what is PNS and what is ANS. Peripheral nervous system. Peripheral nervous system. Autonomous nervous system. ENS. Entericus nervous system. And we already discussed about CNS. Central nervous system. Peripheral nervous system. Autonomous nervous system. Entericus nervous system. So let's come connected and what is peripheral nervous system. So actually in peripheral nervous system, the spinal cord have two roots. You can see in the spinal cords are two types, or they can call two roots. One roots we can see backside, on the backside, one we can see on the backside are dorsal roots. Backside or dorsal root. Spinal cords have two roots. One is backside or dorsal root. Second one is front. Second one is front. Also we can call ventral root. Ventral side root. Dorsal side roots, and the next one is ventral side roots. There are two scientists. One is Charles, another one is Francois Magendine. Charles Bell and he is belong to Scotland, and another one is Francois Magendine. Francois Magendine is belong to France. They did some experiment on this Scotland, on this roots. One is dorsal roots, another one is ventral side roots. What happens? So they destroy the backside roots of the dorsal roots. When they cut the roots of these roots, dorsal roots, they didn't observe any movements in the animal body. When the dorsal roots are damaged, when the dorsal roots are cut by these two scientists, they are very carefully observing the animals. They cannot see any movements in the body. When the ventral side roots are not cut, even a slightly touch, they can see the muscles movements in the animal's body. Muscles movements in the animal's body. So even the dorsal roots are cut, we cannot see anything, but the ventral roots are even slightly touched. We can see the huge movements or animal's body movements in the ventral roots. Finally, they discover this dorsal root carry messages from body parts to the brains. Ventral roots carry messages from brain to the body parts. When the dorsal roots are cut or damaged, nothing will happen. Even the slightly touched by these ventral roots, we can see the huge differences or body movements in the animals. This is about PNS, the one who discovered Charles Bell, Scotland, and Francois Magendine. There are some small diagrams also given in your textbook. Sometimes they will ask this diagram, peripheral nervous system. Please draw the diagram and label the parts. Peripheral nervous system. So next one is autonomous nervous system. What is autonomous nervous system? They are involuntary movements. They are not in our controls. But automatically it will happen. It's not in our control. For example, when you see the dark light through our eyes, so we cannot see them directly. Automatically our eyes will be closed. When you enter into the dark room, what happens? We cannot see anything surrounding us. What happens? The pupil dilation will start increasing size. After a few minutes, we are going to observe what is there inside the rooms. When you come away from the dark room, immediately we cannot see anything. So the pupil size, the dilation of the pupil size will be started decreasing. It will happen automatically. It will be controlled by autonomous nervous system. In the autonomous nervous systems, we can see sympathetic and parasympathetic. Sympathetic, parasympathetic. These both are involuntary movements happens in the body. They are under the control of autonomous nervous system. For example, dilation of pupils. Dilation of pupils are controlled by sympathetic, and constrictor pupil is controlled by parasympathetic. So I think few years back, 2 years back, the 4 marks question they have given from these tables. They have given the table diagram and the parasympathetic and the sympathetic. There are some questions, table and questions. It's easy to write. And inhibits salivations, and parasympathetic is stimulate salivation. Inhibits and stimulate. There are so many examples there, like relax bronchi, relax bronchi. Where bronchi we can see, where bronchus we can see in the lungs. Trachea will divide into bronchus, bronchioles, bronchi. So the relaxation of bronchs in the sympathetic and the constrict of bronchis. Constrict of bronchi is parasympathetic. And acceleration of heartbeat rate, inhibit of heartbeat rate, acceleration of heartbeat rate, contraction and relaxation. Constrict are parasympathetic, relaxation is sympathetic. Heartbeat rate started relaxation and contraction and relaxations. Next one is increased blood pressure. Blood pressure will increase or controlled by the sympathetic, and decreased blood pressure is a parasympathetic. Increase and decrease. Next one is inhibit pancreas. Inhibit pancreas comes under the sympathetic, and stimulate pancreas comes under the parasympathetic. Inhibits and stimulates. Decrease secretion of digestive juices. Decrease secretion of digestive juices are sympathetic, and increase stimulation of digestive juices are parasympathetic. Decrease and increase. That is the one difference. Everything are increased. Next one is relaxation of urinary bladders comes under the sympathetic. So relaxation of urinary bladder. Constrict of urinary bladders are parasympathetic. Inhibits comes under the sympathetic, and constricts and stimulations comes under the parasympathetic. These are the difference between the sympathetic and parasympathetic. So in your textbook they have given everything. Just once you look at what happens in the textbook, they have given sympathetic and parasympathetic. Left side they have given sympathetic, and right side they have given parasympathetic. Okay, once go through the differences. So where is increase is going to take place, decrease is going to take place in the bodies. So this is about the autonomous nervous system. The last one is ENS, entericus nervous system. Entericus nervous system is a difference when compared to the CNS, PNS and ANS. This is talks about the stomach. Gut, this is talks about the stomach. There are more than 100 billions of, even scientists also they couldn't understood about this ENS. There are different types of nerves, some different types of enzymes is going to release in the stomach. So what happens? They don't know. We will discuss this ENS in next classes. So today we discuss about what is PNS, peripheral nervous system, and what is ANS, autonomous nervous systems. So diagram is there. Please draw that diagram of peripheral nervous systems and write about these lines. Autonomous nervous system, you have to write the differences of the sympathetic and differences of the parasympathetic. You have to compare both the direction of the pupils and constrict of the pupils. Constrict of the pupils will in the control of the parasympathetic, direction of the pupils in the control of the sympathetic pupils. This is the today homework. You have to write CNS diagram, explanations, ANS the differences. No need to draw the diagrams. Just you have to draw the sympathetic and what is parasympathetic. Okay? Thank you, students.